Here we are with our first PSAT drill, and I want to focus on some extreme concepts or concepts that I know for a fact they're going to test you on. So I'm going to start with equations and inequalities. Okay, and one of the first questions they say to you is, an equation is a statement such as, if I give you 3x plus 5, it's equal to, in this case, 17, and they expect you to be able to solve for this. One of the things that they reinforce here is the main idea that whatever you do to one side of the equation, the other side has to also have that same experience. So in other words, if I'm subtracting 5 on the left-hand side of the equal to sign, then on the right-hand side of the equal to sign, I must also do the same. So this leaves me with 3x is equal to 12, and at this point we're back to square one, where I divide by 3 on the left, I have to divide by 3 on the right, canceling this out on this side and leaving you x is equal to 4, which is your solution. Once again, if you've been in my class, you know that I always tell you to remember FAR as an acronym to remind you fractions, absolute value, and anything with radicals. You always have to check for extraneous solutions. So in this case, we don't have that, so we don't have to worry for this particular example. The other concept that they ask you here, and I'm going to give you an example question where they actually give you the following. So they say in the equation, and then in this equation where t is equal to u, v, and w, all variables. Okay, and this will be the case in any case where we are assuming these are all positive. So in this case, we are going to express, they want you to express, and be careful with this language. They want you to express w in terms of the variables, and then they ask you obviously the remaining variables that are here, which are t, u, and v relative to this question. All right, so in this case, all they're asking you is to basically solve for w. And so what would be the way to approach this? So if you have t is equal to u, v, and w, and I'm trying to solve for w, obviously my next step is going to be to simply divide by u, v on both sides. That cancels, and that is your answer. All right, and so that's one of the easiest things that they're going to ask you to do. All right, so one of the things that I want to bring to your attention as well as this are the inequalities. So let's talk about inequalities in our science, because I hear a lot of students make silly statements sometimes. So the inequalities, if I have less than, which always looks like this and faces this direction, versus greater than. Okay, so I want you to think of this in terms of left and right, if that helps you. If this is the left of an equation, whatever's on the left is less than whatever's on the right. The smaller value or the smaller edge of the inequality is facing the left. If, again, we're on the left and I have the larger part of the inequality facing me, the smaller part is to the right. This is telling me that whatever's on the left is greater than whatever's on the right. So the only difference between less than and equal to is if I add, so if I have less than and equal to, they say or equal to, so less than or equal to, and then you obviously have greater than or equal to. Okay, now what I want to do here is also bring to you a reminder of one of your previous assignments. Bear with me, let me pull it up. So on the PSAT test that we gave you, I believe this is test 3. In this question, they give you a greater than question, less than, in this case greater than, right? Look at the language expressed right here at this part where it says where Taylor's charge is greater than Allen's total charge. And so you basically, when you set this question up as an inequality, you actually solve for two equations, solving for x, and you ended up with the correct answer. Hopefully you ended up with x is greater than 4. This is a perfect example of how they're going to blend these concepts. So you have to be able to, first of all, set the equation, which I always say to you, look for the word per in these types of questions. Per helps you already see or know that that is where the x is located, and technically the 850 is that rate per x, whatever that value may be. They may use h, they may use x, it doesn't matter. The fact is, you know that that is per hour, and that the 15 is not per, the 15 is a standard. It is the cost that is going to be present no matter what. The same thing happens for Taylor, and Taylor's per, okay, so that's what I'm going to call it. Taylor's charge per hour is $9.25. So in this question, you should have set it up as two linear equations in a sense, but one greater than the other. And be careful with how they asked you to set it up. They said, what are all values of x for which Taylor's charge is greater than Allen? So notice that they give you Allen first. So they're trying to mix you up there in a sense. So if we look at, again, the fact that we're looking at Taylor's charge is greater than Allen's charge, well, Allen's $15 plus 850x, so this is 15 plus 8.5, 0, let's call it x. Here's Taylor. Taylor is basically $12 plus 9.25 x, and this inequality goes here. Now, I want to just remind you that when we're dealing with inequalities, remember, anytime you divide or multiply by a negative, you switch or you reverse the direction of the inequality. Okay, in this particular example, we would have subtracted, perhaps subtracted 12 on both sides. And in that case, I'm going to subtract the 850x on both sides. All right, and now the inequality stays in the same direction. Nothing's changed yet. And so we're going to take our example. And let's take the 925 minus the 850. And then on the opposite side, obviously 15 minus the 12. So this is 0.75. X, don't forget the x, is greater than 3. And our last step here is simply going to be divided by 0.75 on both sides. This cancels, and you're going to end up with x is greater than 4. All right. So that I just wanted to remind you of that question. All right, let's go back to our notes here. They do give you an example that we're going to look at. They give you this very easy one where they say, well, what if instead this was 3x plus 5 is greater than 17? So we're going to subtract that 5 on both sides. You still end up with 3x is greater than, in this case, 12, and then divide by 3, nothing changes. We divide it by a positive, so x is going to be greater than 4. Yay! What they're expressing here is the difference is if instead this were negative 3x plus 5, and this were greater than 15, as an example. They use 15 in this case. So if we subtract the 5 on both sides, we end up with negative 3x is greater than 10. And if we divide by negative 3 on both sides, then we are going to end up with x is less than negative 10/3, which is basically 3 1/3, big deal. So these are just examples of reminding you when you multiply or divide by a negative, reverse the inequality. The direction of the inequality. All right, just a couple more notes and examples, and then I'm going to give you a drill to do is quiz 1, and it is timed, so I need you to be on your toes. So the next question I want to talk about is 8 is greater than or equal to 2x minus 6. Okay, so in this case, they ask you the question, the inequality above, and so this is a PSAT question from a former test, can be expressed as which of the following? And then they give you 4 selections. They give you A, where they say x is less than or equal to 2. They give you B as x is less than or equal to 4. They give you C, where x is less than or equal to 6. And they give you D, where x is less than or equal to 7. So all you need to do there in that case is solve. So let's begin by solving. I'm going to start up here. I'm just simply going to add that 6 to both sides. You already see that this is going to give me 14 is greater than or equal to 2x. And therefore, when I divide by 2, which is no big deal, it's a positive, so yay. Our answer choice should be, in this case, D. Because you end up with x is less than or equal to 7, which is, if you reverse this, notice that I'm going to keep the x on the left now, and the smaller part of the inequality is facing the x. And notice that that matches perfectly. All right, that's a very easy question. Now, they do ask you to learn simultaneous equations. Obviously, I just showed you one example, so let me show you some more. So simultaneous equations, basically systems of equations, right? That's in essence what they're asking you or telling you here. Now, just to recap systems of equations, remember there's 3 general equations we need to know. We have the one solution. In this case, you're going to get an actual x value and actual y value. Then we have the no solution one, where we end up basically with parallel lines. So you can look for the same slope, that would be a hint. So this is the no solution. It's basically a null set. And then you have the infinitely many solutions, which is in essence the same line. It's just overlapping. Basically, you would have something like to the effect of, you know, y plus x is equal to 6, and then they might give you something like 2y plus 2x is equal to 12 as an example. And you can already tell that if I divide all three of these by 2, then I have the same equation as I do there. So we refer to this one as infinitely many solutions. If you recall in class, during one of the sections, I believe it was section, I want to say 1.7, we talked about solutions where, or actually it was 2.1, we talked about solutions where you end up with an answer like 7 is less than -2. That is not true. This is a false statement. And as well, this is also a null set. In another example, we had something to the effect of 8 is greater than 3. Well, this is true, and it will be true for all values. So that is a connection between a concept we talked about in class. All right, so let's take a look at an example that they give you here in the text. So they give you -c plus d is equal to 5. They give you c plus 2d is equal to 13. And then they ask you what is the value of c if the solution to the system of equations above is c comma d. All right, so basically they're just asking you to solve for the system. Now, right off the bat, do you notice that you have a -c and a positive c lined up? Hint, hint. And then you've got this remaining part of the solution. So the c's are going to cancel right off the bat. That's going to leave you with 3d is equal to 18. And in this case, d is equal to 6. Okay, if d is equal to 6, now we need to find c. If I know that d is equal to 6, I can take -c plus 6 is equal to 5. I'm going to subtract the 6 on both sides. Notice that I end up with -c is equal to -1. But remember, we don't like negatives for leading variables. So in this case, multiply by -1. So this changes to positive c equals 1. Okay, so that's the hint on that one. Okay, in the next question that they throw your way is a word problem where you have to apply this. So it says a debate team. So a debate team takes part in 12 different debates over a season. A win is worth 3 points. And the loss is worth 1 point. Just for participation. There are no ties. If the debate team, here's your question. If the debate team scores a total of 30 points, what is the difference between their number of wins and number of losses for the season? Okay, so you see a question like this and you're probably wondering, where am I getting two equations? But remember, one of the first things they said was they took part in 12 different debates. So that we know that there's a total of 12. And then they start with, in terms of the wins versus the losses. So we know that we have a 3, let's call it 3W plus 1L is equal to 30, because we know that they accumulated 30 points. This is the total amount, which means that whatever number they participated in wins plus whatever value in losses was equal to 12, because this was their total 12 participatory events or debates in this case. There's your two equations. So they basically now are asking you in this question, what is the difference between their number of wins and losses? They're really asking you, what is W versus what is losses, L? So, okay, so let's go ahead and let's solve for this simultaneous equations. So we know that we have these two equations. We know we can solve for one in terms of another. Since these are both 1L, this is 1L, 1W, what if I multiplied all of this by -1? This will give me, and I'm going to break it down here, this is going to give me -W minus 1L is equal to -12. So I'm left with 2W is equal to 30 minus 12, which should be, in this case, 18. So if I divide by 2 on both sides, do you see how I get W equals 9? And if W equals 9, that means that L has to equal 3, because the total has to be equal to 12. Okay, you can go back and substitute it in and solve. That's one way you could do it, or you could just use common sense. So in this case, if I were to look at the answer the question, the difference between their number of wins and losses, it would be 9 minus 3, which is actually 6. So 6 is your correct answer, because that is the difference between the wins and losses. So be careful with the questions. Sometimes the questions seem direct, but they're really not. Okay, I want to talk to you now about some math verbiage, which I want you to become familiar with. So whenever you say or you see language such as is, are, were, did, does, or costs, they're referring to equal to as a symbol. That's what that means. If you see the verbage, what, or basically any unknown value, in that case, I want you to think of a variable. That variable could be anything. It could be an X, it could be Y, it could be a K, it could be anything in the alphabet soup. Anything you choose. If you ever see the word more or some, they're talking about addition. If they're talking about less or difference, then we're looking at a negative. If we're looking at of or times or the word product, we're talking about multiplication. And anytime they talk about ratio, quotient, or they talk about out of, or even per, we're dividing. Don't confuse this with the equations where I say 850 per hour. Okay, so let me give you an example question. I'm going to type it in here real quick so you can follow me quicker. Let me see if I can make this font a little bit more readable. All right, there you go. So Drew is distributing water bottles during a marathon. Okay, she starts 3,500 bottles of water and distributes an average of 70 bottles each hour. Sorry about the typo. I don't like typos. It says, which of the following best demonstrates the relationship between the remaining number of bottled waters we'll call them W, and the amount of time H in hours Drew spends distributing water bottles. All right, and so they're going to give you now 4 possible answer choices. So they give you W is possibly equal to 3,500, H minus 70. Then they give you W is equal to 3,500 minus 70h. In C, they give you H is equal to 3,500 minus 70W, and D gives you H equals 3,500 W minus 70. So those are your 4 answer choices. So I want you to reread this for a second and think about the last part of the question, the actual question stem. The actual question stem says, which of the following best demonstrates the relationship between the remaining number of water bottles W and the amount of time in hours Drew spends distributing the water bottles? So the variable W is basically defined as the number of remaining water bottles. So the equation should be set to equal to W. Given that information, eliminate answer choices C and D, because we're not looking at H. Now determine where H should go. And so if you notice, they have the 3,500H on A, and on B, they have the 70 with the H. Understand that Drew hands out 70 water bottles per hour. So this should have 70H attached to it. Your answer, or the correct answer choice here, would ultimately be answer choice B. That should be your answer choice. Okay, take that question in, and then I'm going to hand you another one. Let's see how you do on this one. I have another word problem for you, and this is something that you need to get really good at. So let me write this question out for you. Okay, so in this question, it says a sports memorabilia store sells, I missed the word sports, memorabilia store sells a number of rare cards for $20 each. They call the cards R, or refer to them as letter choice R. It also sells a number of common cards C for $2 each. On a given day, a sports enthusiast purchases 40 cards for a total of $296. Which of the following systems of equations illustrates the relationship between R and C? So let's take this in little by little. So we have 2 types of cards, don't we? We have rare cards. These are the R, and common cards, which are C. And we know that this sports enthusiast purchases 40 cards in total. So we know that R plus C equals 40. I do know that each of the rare cards is $20 each. And I also know that the common cards, well, these are just $2. So I know that I have 2C and 20R, which added together, in this case, has to equal 296. And that is basically answer choice D. Okay, so you should use the process of elimination and start to think of these questions in this manner, and it will help you. Just notice that I'm looking at it as a quantity. There's a quantity equation, and there's also a total equation. So I always look at the total, how many. So I always look at this as how many versus how much. In other words, the value, which is the 296, versus a count. Think of it that way. I do want to discuss one more question with you, and bear with me. I actually want to look at this question with you again, because this is another question that I know that a lot of you struggled with, and you didn't know which of the variable or of the equations to use. And I want you to look real carefully at number 30, and let's discuss this together. So as we read the question, you notice that in essence, they are giving you, let's see, what are they giving you? They give you 100 meters per second, and they're asking you, in this case, given gravity, which is 2 times, it'll be 2 times 9.8 times h, basically. And what throws you off in this question, I think, is, in essence, you don't know which of the equations to use. So they do tell you an initial velocity right off the bat. I want to bring to your attention that initial velocity will look like this. So if I'm going back to that question. I'm looking at the formula where I have, in this case, that velocity squared is equal to the initial velocity, which is the v sub 0 squared, minus 2 times gravity times the height. They do give you initial velocity in the question. They do tell you that v sub 0 is 100. You do know that gravity, well, that's 9.8. And what are they asking you for? They're asking you for h. There's h. This formula has everything you need. So we know that this is 0 squared. That is going to equal 100 squared minus 2 times 9.8 times the height. So this is going to give you, if I add this part of the equation to both sides of this, I'm going to end up with basically 100 squared equals 19.6. So 19.6, I'm going to add it to both sides, basically. 19.6h is equal to 100 squared. And if I divide by 19.6 on both sides, I'll have my height. Height, when you do the math, will end up being 510 meters. Remember, they give you the value initially, I believe, in kilometers, if I'm remembering correctly. No, they do give it to you in meters initially, so you're fine. You don't need to do any conversion. So they tell you initial speed. Initial speed is always this, v sub 0, FYI, just remember that. So I don't want you to get stuck on which of these. I initially thought it was position time, but then I recapitulated and realized that they didn't give you time, per se. So we don't really use that. You don't need to use that. Okay. I just wanted to discuss that question with you because, again, it's one of those where you have to make a decision. All right, so I'm going to go ahead and stop this video here. Go ahead and try the quiz and see if you can do it as quickly as it is asked of you.